some in-person trainings on a more personal level. So just please give me a call or shoot me an email, and we'll get you taken care of. If you got any questions today, just raise your hand, type out your question, and when I get to a stopping point, I will address that question. There is my contact information, my email address. You can also email at training@enertechgeo.com, and I get that email address as well, so it doesn't really matter to me if you email my personal email or the training email. You can also call my direct line there, the 690-3275, and that'll bring directly to me. Or if you just need to talk to one of the technicians in tech support, you can call the 664-5860 number, and that will ring directly back to the tech service pool. So we're gonna just cover some troubleshooting. Obviously, you've got to understand the control sequence and the lockouts to understand how you need to start troubleshooting the unit. How the system works, you know, that's part of the sequence of operation as well. You know, some guys may not have a whole lot of experience on geothermal, but really there's not a whole lot different, you know, with a geothermal than there is with a standard air source heat pump. And we'll kind of cover some of the differences here in just a minute. Obviously, you need to understand how to calculate heat of extraction, heat of rejection. That's our first basically troubleshooting tool. We can check the heat of extraction or rejection, and that'll tell us the performance compared to what's in the manual. And if it's within specs, then we don't need to, you know, throw refrigerant gauges on the system. Throwing refrigerant gauges onto the system, you know, when it's in a low pressure lockout, we probably don't want to do that right off the bat. We do have basically a sealed system, kind of like a refrigerator. It's got a certain amount of refrigerant in it. So every time you put your refrigerant gauges on there, you're going to pull some out. So if we don't have to put the gauges on there, we're not going to. Obviously, you have to understand superheat and subcooling. If your heat of extraction and rejection don't work out, then we would go put the refrigerant gauges on there, check our superheat and our subcooling, do some refrigerant diagnostics. We got to know, you know, obviously where to start looking when we get a fault, or, you know, the unit's not operating properly, you know, our superheats or subcoolings are off. If there is a lockout, the lockout board, you know, will tell you high pressure, low pressure, flow, that kind of thing. So it'll kind of give you an idea of where to start looking. So we'll go ahead and dive in here. So the big difference, we got a geothermal on the left and an air source heat pump on the right. Basically, the only difference is, you know, it's the same principle. There's just, instead of an air to refrigerant heat exchanger, you know, on the outdoor portion of a standard air source heat pump, we have either a coaxial heat exchanger or a braze plate, sometimes tube and shell, normally a coax or a braze plate heat exchanger. So, which is a water to refrigerant coil. So instead of a fan on the outdoor unit, condenser fan motor, now we've got what we call a source pump, and it'll flow the water through rather than air. So we're using the same principle. We're just using water instead of air on one side of the unit there. So it's just a different medium that we're using. We're using the ground as our heat sink or our heat that we're pulling heat out of instead of the air. Basically, we've got to have water flow for the heat pump to operate properly. That's whenever you're calling the tech support, a lot of times that's what we'll ask you first is water flow. We've got to have water flow or the unit won't operate properly. So we got to make sure our pumps are working. And if you've got a water to water unit, then you've got water flow on both sides, the load and the source. So you got to make sure that we've got water flow on both sides. You got to have a proper energy source or energy dump. So your loop field, it needs to be sized properly. And again, we've got to have proper flow through there as well. So we got to make sure we're designing that loop field properly. If we've got a packaged unit, we've got to have airflow. Airflow is relatively easy to know. You can look at the ECM board. You can count the flashes on the ECM board, and it'll tell you how many CFM that the ECM is moving. You can also put your hand over a register or something like that. See if you got some airflow. A lot of times you can hear the blower running. You can hear it change speed. So it's a little easier to establish the airflow. Water flow is a little bit more difficult because we can't see the water flow. We can't really feel it, and we shouldn't be able to hear it. So we have to do pressure drop and things like that to be able to figure out if we're moving water flow. Obviously, we've got to have a proper electrical power supply to the unit. A lot of our units are 208, 230 single phase, so they come wired from the factory for the 230 volt. So if you have the lower voltage, the 208, make sure you're switching the taps on your transformer. We could run into an issue there with getting some low voltage out of the secondary side of the transformer if the tap's not hooked up properly. So you gotta have proper electrical power supply. Obviously, we need the compressor to be operational, the blower motor, anything inside the unit, contactor, reversing valve, all those components need to be functioning. If one of those is not functioning, we really can't expect the unit to operate properly. So make sure that we've got a compressor that's running, and it will run in first or second stage. If it's a two-stage unit, we normally will check running numbers when it's in second stage. So make sure it will upstage. Make sure your fan motor switches speeds up to Y2 if you're in Y2. So just make sure all the components are operating when you go to diagnose the unit. So water flow, again, we got to size the loop field and energy source properly. We also have to size the flow center properly as well. We can't really throw a single pump flow center on a 7-ton unit. We're not going to have enough water flow. So we've got to make sure we've got enough pump and we've got enough pipe in the ground to be able to transfer our heat properly. Make sure that when you're installing the unit, and sometimes after the fact, you'll still get some air in the system, but we need to flush all that air and debris out of the loop. If we don't, air is an insulator. It will cause pumps to fail. Pumps tend to cavitate. They'll start running real hot. So if you ever go up to a pump and you put your hand on it, I know we touch stuff a lot in our industry, grabbing refrigerant lines, tops of compressors, feeling how hot they are. A good sign that you've got air in your system on a pump is that pump will be warm. That pump is liquid cooled. The shaft is on it. So if air gets in there, then it doesn't get cooled, and it'll cause your motor or your pump to fail prematurely. Make sure we've got antifreeze in the system. The majority of the time, we design the systems for about 30 degrees as our lowest temperature on a perfect day or a design day. We get times when we're below our design temperatures, so we know we're going to drop that loop field temperature below that freezing at times. And so we've got to make sure that we've got proper amount of antifreeze in there so it doesn't freeze up. But I would highly recommend don't just, obviously dump straight antifreeze in there, because then the antifreeze becomes too thick or too viscous and it doesn't transfer heat as well. Lock out prematurely, and it can also cause problems with your pump as well. Airflow, again, airflow is relatively easier to establish than water flow. Make sure we're always sizing the ductwork properly. Plenum design is important on our packaged units. We don't have a heat exchanger to straighten up our airflow before it dumps out the top of the unit. So we do like to see 12 inches above the unit of straight ductwork in order to get that airflow from tumbling out of the top of the unit. It wants the blower is right at the very top of our units. If we have let's say just a tease right off the top of the unit, the air will tend to want to tumble right there, and it's not going to flow through your ductwork properly. So make sure we're always sizing the ductwork for proper CFM and static pressure for the fan motor. Proper duct fittings, again, we talked about the plenums, your drops, your elbows. We would prefer that you have a long radius 90 for your return and not just a square duct with a hole cut in the side of it and shoved up to the unit. Again, the recommendations, I know that there comes times when you're in a tight area, maybe a closet or something, and you don't really have a choice on how you got to do your ductwork. Again, with me having been in the field, I kind of understand sometimes the hassles that you deal with in the field. So again, the recommendations, if you have blower noise and stuff, these are the kind of things we're going to look at. But if you can change it, you can't. We'll have you change it. If not, it is kind of what it is. But just make sure you're designing your ductwork properly. Make sure you're watching your filter size, the MERV rating on it, and the rating CFM. Some of these filters have quite a large pressure drop across it, so just be careful with some of the ratings on your air filters. Zoning, you can run into a problem with zoning. We do like to make sure that you have a bypass damper on your zoning. So if you have a small zone that's calling, we don't overload the unit and cause it to lock out on low pressure or high pressure because we're not getting enough airflow across that coil. So we can definitely do zoning. Just make sure we're installing a bypass damper, whether that's a barometric or a electronic bypass damper. Electrical power supply, make sure that they've got proper transformer, and we're not talking about the transformer in the unit, we're talking about the transformer on the pole. So, if they had a gas furnace in their home before and they're installing a geothermal unit, they may need to upgrade their service. So make sure we're always checking that on our electrical power supply. Make sure they've got proper service size, panel size. They've got, if you're installing a geothermal unit with electric backup heat, you're going to have 2 power sources to the unit. It could be like an 80 amp breaker for the electric heat and probably a 50 or 60 for the geothermal unit. So you got to make sure they got enough access in their service panel. Proper wire sizing is important. We do list in the manual the proper minimum wire sizing for a certain distance in the manual. So make sure we are installing proper wire sizing for the heat pump as well. Obviously, we've got to have thermostat wiring hooked up. You can make the unit run without a thermostat hooked up, but make sure that you've got your thermostats wired in and you're not stapling it. There's no shorts in the electrical wire, anything like that. The first thing you do when you're going to diagnose a unit is try to find out as much information as possible. I know sometimes customers they don't know a whole lot about their geothermal system or their heating and cooling system. They may say, hey, well, it's making a growling noise or a thumping noise or something like that. But you kind of have to decipher what they're trying to get across. But so just take a minute and listen to them, listen to what their problems are. They live in that home and they're there quite a bit. So when something changes, they realize it pretty quickly. So just take a minute, listen to the customer and see what they have to say about what's going on with the unit itself. We always start on water flow first, airflow second. It's easier, again, to know if you have airflow. If you've got a blower bearing unit, you can hear the blower, you're standing right there. So water flow first. So obviously we'll start up the system, and we need peak pressure temperature ports on the water lines. Whenever you're installing a unit, whether it's a water-to-water unit or a forced air unit, make sure we're installing pressure temperature ports. It's hard for tech support to know what the water flow is without pressure drop. So the only other way to know if you don't have pressure drop is to drain it into a 5-gallon bucket and time it and see how long it takes. That's really not a good way to go about doing it on a pressurized loop field. So if you've got a water-to-water unit, make sure you're installing pressure temperature ports on the load side as well, because we've got water flow there. So we need to make sure we've got proper water flow on the load side as well. So we'll always start out with water flow first. Make sure you get as much information. If you've got some startup sheets, you may want to take a look at those. You can give us a call in tech support with the serial number, and we can look and see if there's been any what we call incidents or calls to tech support on that unit. We can also look up any kind of warranty claims that have been made on the unit or anything that's really happened to the unit. We have basically a unit snapshot we can pull up with the serial number. So we can see if, you know, a TXV has been replaced a couple days ago, or they had a compressor replaced 5 years ago, or anything like that we can see on that unit. So just give us a call and we'll pull that up with the serial number. Just make sure we don't necessarily have to have the model number. We can get the model number if we have the serial number. Step back and analyze what the problem or complaint is, and then systematically evaluate what might cause the situation before just diving in. Again, you know, analyze the situation. If you've got a low pressure lockout, I don't want you to immediately put your refrigerant gauges on the system. We'll go ahead and check our flow first because it could have a flow problem. And if we don't have to put our refrigerant gauges on there, we don't want to. Again, it's a sealed system, so we want to make sure that we're not pulling refrigerant out every time we put our gauges on it. Once the system has been analyzed and the installation according to manufacturer specs, perform the heat of extraction, heat of rejection. When you do heat of extraction or heat of rejection, we're going to establish flow when we do that, and then we can also see our temperature difference. So heat of extraction, heat of rejection, we have our own webinar on it. So if you're not real sure how to do that, check out our YouTube channel, or I try to do heat of extraction rejection webinar once a month because it's that important. It's such a good diagnostic tool as long as you have the IOM, but always perform the heat of extraction or rejection first. If the heat of extraction and rejection doesn't check out, or the heat pump problem is still suspected, then we'll go ahead and move on to refrigerant diagnostics. We'll check your superheat and your subcooling. Look outside the unit first. So outside the unit would be basically water side. So make sure your pumps are running. Look at your flow center. If it's a 2-pump flow center, make sure both pumps are running. If you've got one of those little spinning tools, you can hold it up to the pump and see if the impeller or the shaft is spinning. It doesn't necessarily mean that your pump is moving water. It just means that the shaft is spinning. It could be the impeller's busted off and it's not moving any flow. The best way to know if a pump is moving water is to check the amp draw on the pump. The pump will say what it's rated for. It'll show run load amps right on the pump. Normally we're a little bit under that, but we should be fairly close to that. You know, if you're pulling on a 2699 pump like 0.3 amps, that's probably not doing any work. So it could still be spinning, just not really doing any work. Amp draw will tell us the amount of work that something's doing, how much power it's pulling at one time. So it should be fairly close to the run load amps. I think actually a 2699 pump is like 0.8 amps maybe, and the 26116 is like 1.1 or something like that. So you should be fairly close to that, and that'll tell us that we're moving water. You can also do pressure drop, and that'll tell us if we're moving water flow as well. Check your air side, make sure your blower is running, it's spinning in the right direction. Look at your ECM board, count the flashes. Again, one flash equals 100 CFM. So there should be a chart right there in the near the wiring diagram, the sticker, that'll show you what the CFM should be if you're in Y1, Y2 electric heat call. So you can kind of compare that blinking to how many CFMs you should be moving. Make sure all your controls are working. If you suspect a control issue, all of our units have a removable terminal strip where your thermostat wires wire in. So you can remove that terminal strip, take the thermostat or your aquastat or whatever you've got there out of the equation and jumper out the unit. Takes away some of the time delay in the thermostat, and it allows you not to have to run up and down the stairs to turn the thermostat on and off. So just pull that terminal strip, jumper it out, and run the unit. Once you have determined outside the box is correct and operational, then we'll go ahead and move to the inside of the unit. So if the equipment will not start, so it's, you know, the compressor is not running, the fan's not running, outside the unit, what would we want to check? Obviously, we want to make sure we've got power at L1 and L2. We got proper voltage there. You know, if you don't have proper voltage coming into the unit, then obviously we need to check our breakers. If you've got a disconnect, we need to make sure that disconnect is okay, that the blades are in the proper position. And if it's got fuses in that disconnect, make sure those fuses are good as well. Check your low voltage wiring. There is a fuse on the ECM board for the low voltage side of it. And again, if you do suspect the low voltage, just remove it from the equation and jumper the unit out and see what happens. If you look at the lockout board, there's a status light on the lockout board, a green status light on the very bottom of the board. If you've got low voltage to the unit, that should be flashing all the time. The only time that will not flash is if you pull the test jumper or flip the test into the off position, and that light will go away. So as long as you know that the jumper's in place, so the dip switch is in on, that light should be flashing. If it's not flashing, that's a good indication that either there's no high voltage power to the unit, or there's a little 3 amp fuse on the ECM board that's tripped. That's really the only low voltage fuse in the circuit, is that 3 amp fuse on the ECM board. So inside the unit, there is a resettable switch on the transformer as well. So make sure that that's not been tripped, and check your transformer circuit. You can go ahead and put the unit in test mode. It'll speed up your time delays. Now, when it's in test mode and it speeds up, if let's say you have a high pressure lockout, our high pressure lockouts now, if it sees an open switch, the unit will not even try to start the compressor. And when you're in test mode, it'll do it so fast that it won't even give you what we call a soft lockout. It'll immediately give you a hard lockout. And so you won't even try to start. In test mode, those time delays in between restarts are shortened. So all of a sudden it'll go into a hard lockout and not try to start. So when you do have it in test mode, it'll just speed up your time delays is what that does. And the status light will go out on that lockout board. A quick note on that, when you're in test mode and the light goes out, if you leave the job and you forget to put it back in normal operation mode, and you know, if you're like me, you kind of think about things after you leave, and you know, you get home and you think, well, I don't think I put that test jumper back in. I'm gonna have to go back out there. It's not a huge issue. After in 1 hour, it'll realize that you forgot to put it back into normal mode with the time delays, and it'll revert back to its time delays. The status light will stay out on the lockout board, but it will revert back to its normal time delays. You may want to make a note that to put that back in next time you're out there, but there's not a huge need to make a special trip to go back out there. Just a little side note on the test. Again, pull a T-stat and use the jumpers. I do offer a little terminal jumper kit. If you'd like one, I'll send you a little removable terminal strip, put a few thermostat wires on there for you. Just shoot me an email with your address, and I'll make one up real quick, and I'll send it out in the mail for you at no charge. Make sure we're checking the compressor capacitor. Look for any swollen or bulging capacitors if it's leaking any kind of fluid. Capacitors fail quite often, I should say. I shouldn't say quite often, but capacitors do fail. So make sure you're checking the capacitor. Look at the contactor. See if the contactor is pulling in when you give it a Y1 call. If it is, there is a little cover on that contactor. If it's pulling in, obviously check voltage on both sides to see if you're getting voltage through it. And if you're not, you may want to remove that cover. I know, I don't know, maybe 2010, 2011, they had a problem with contactors and the spring would break, and it would still look like it was pulling in, but it wouldn't close the contact. So we haven't really had that issue in a while, but sometimes spiders will get in there and cause it not to make good contact. So check that contactor, pull that cover off, and see if that contactor is pitted or if it's actually pulling in all the way or not. If the contactor pulls in, but the compressor does not start, check the voltage supply on the load side of the contactor. So that's the T1 and T2 side. Obviously, we need, our 240 volt or 208, whichever voltage you have, we need to get it across that contactor. Again, check the capacitor, check the microfarad reading on that capacitor. It needs to be, normally I think it's about 5% of what it's rated for. So make sure that the capacitor is operational. Check the compressor, feel it. If it's real hot, you can ohm out the compressor and see if it's in internal overload. If it's real hot and it's in internal overload, you may have to somehow cool it off. But if it's in a home where you can't put water on it, it's going to take a while for it to cool off on its own. So if you can't get ice bag on top of it, or you can't cool it off manually, then you may have to just shut the unit off and come back later when it has cooled off. If it's an internal overload and it's not hot, it could be stuck in internal overload. Sometimes you can take a rubber mallet and hit the top of the compressor and it'll reset it, but more than likely it's a little thermal disc inside there. If it gets hot one too many times, it becomes weak and it may stick open. So if that's the case, then the compressor will have to be replaced. There's no just replacing the internal overload. That compressor is failed because of internal overload. I would highly recommend that you fill out a startup sheet once the compressor has been replaced and give us a call on tech support with that information, and we'll take a look and see if there's something that's caused it to go into internal overload too many times. Just trying to stop another compressor from having the same failure. Make sure you check all the electrical connections, and this is true even on an initial startup of a unit. Things happen during shipment. Wiring can sometimes become loose, and if that happens, we don't make good contact. We can overheat wiring and melt wiring and that kind of thing. But make sure you've got all the connections are tight, especially on your contactors, that they're making good contact. Ohm out your compressor windings and see if it's in internal overload or whether the windings are open or shorted. Just find out if the compressor is still good or not. If you've got a high pressure lockout in heating mode, high pressure lockout in heating mode would be on your load side. So it's a water to water unit. We're going to be looking at our load hydronic zones. And if it's a forced air unit, we're going to look more towards your blower, your airflow, the filter plugged up, something like that. So outside the unit, we want to look for airflow interruptions. So dirty filters, blocked return grills, blocked supply registers, restricted ductwork, zone damper stuck, no bypass damper if you've got a zone system. Obviously, we want to look at your return air temperature. If for some reason it's too hot, you may want to check for some ventilation air issues, some ductwork problems there. Maybe you're getting too much bypassed on your zoning system, so you're overloading the unit with high return air temperatures. Obviously, inside the unit, the blower is an obvious sign. If you ever see the blower rocking back and forth on an ECM, it's trying to find direction, so it's confused, and more than likely the module on the motor is the issue. It seems like that's normally the case anyway, that the module is what fails on the ECMs and not the actual motor itself. Not that I haven't seen motors fail, but it's normally the module. So obviously check your blower, make sure the coil is clean. If they've run it during construction, that's probably going to be a bad thing. So make sure we're not running it during construction. So look at the coil, make sure it's not plugged, make sure your filter's not plugged up. If someone's done some work to the unit, it could be overcharged. So make sure we're checking our superheat and our subcooling. You can also, if you don't really understand your superheat and subcooling real well, you're not real familiar with it, you can always remove the charge from the system and weigh it out. And there's a weight of refrigerant on the unit itself, and you can kind of compare the numbers, and that'll tell you if it's low on refrigerant. But superheat and subcooling will tell you that as well. Check for a blocked or a seized expansion valve. Normally, I don't see the high pressure lockout when the valve is stuck. But it occasionally will. It basically is going to pump the system down. You could have a high pressure switch issue or a board issue. So if you put your refrigerant gauges on there and the refrigerant pressures don't show a high pressure, then check the switch. And it could also be a board problem too. So if the switch is good, then jumper it out at the unit. If the lockout board still locks out when you've jumpered out the high pressure switch, then we know we've got a board problem, so the board would have to be replaced. High pressure lockout in cooling mode. So now we're going to be looking at our source side. So the loop field, or if you've got an open loop, the pump and dump, but we're going to be looking at the source side of things in cooling mode, high pressure lockout. So water flow. Again, make sure we're always installing pressure temperature ports so we can check pressure drop. Make sure we've got proper water flow. Feel your pumps, see if they're hot. Check your amp draw on your pumps, see what kind of amp draw they're moving. You could have entering water temperature that's too high. If it's late in the year, it's been 100 degrees for a month, and your ground temperature could be getting pretty warm, especially on a horizontal loop field, and your entering water temperature could be getting too high. About the max entering water temperature that we can really deal with is about 110 degrees. And it could be a problem with the loop field itself. Maybe one of the vertical wells or the horizontal loops is airlocked and we're not moving water flow through it. So, if it hasn't been super hot for a long period of time, but they're still running high temperatures, then we need to look more into that loop field, and we may need to flush that loop field again. You could have entering air temperature too high on your return air. Maybe you're pulling outside air. I know I ran into this problem out in Texas not last August, the August before, and they were pulling a bunch of fresh air in and really overloading the unit. I mean, it was 110 degrees outside, so they're really having too high return air temperatures. Inside the unit, the water to refrigerant heat exchanger could be fouled with debris. That's normally what we'll see on a open loop system, so a pump and dump. If you've got a strainer on that water circuit, make sure that strainer is clear. And we have a calculation we can do to see if a heat exchanger has failed. And we don't have to just guess whether it's plugged up. We can actually do a calculation that'll tell us, hey, I know it's plugged up, we need to clean it out. The system could be overcharged. So if somebody, again, has been messing with the system, they've changed the TXV or something, it's possible that there's too much refrigerant in it. It would take quite a bit to overcharge the system and cause a high pressure lockout, but I've definitely seen that in the past. Obviously, a TXV issue, so blocked or seized TXV, or again, the high pressure switch could be faulty, or you could have a board issue as well. Usually our lockout boards are pretty reliable. The high pressure switches, They fail occasionally. A lot of times I see them fail. The collar on the top of them kind of breaks, and it just loses the signal through it. It can't make, it doesn't realize that it's still closed. One thing that is good if the high pressure switch fails and it's not leaking refrigerant, we do have a high pressure switch kit. We have a low pressure switch kit as well, and it'll thread onto your access port, your service port with a T, and then we can thread on a new high or low pressure switch and still be able to check refrigerant pressures. So the only time we really need to get into the refrigerant circuit to change a high or low pressure switch is if it's leaking refrigerant. Low pressure lockout in heating mode. This would be the source side as well. So we're looking at the loop field or the pump and dump. Outside the unit, if it's the equipment's installed in a low temperature area, we could have a problem with the compressor wanting to start on a cold startup, and you may want to put a crankcase heater on the unit. Water flow, again, we're looking at the source side. Look at your water flow. Check pressure drop. Make sure you haven't lost a pump. Make sure that the water temperature is not too low and it's freezing up. You could have low antifreeze, so make sure we're checking our antifreeze levels and our water temperatures as well. You could have low return air temperature. If that's the case, you may want to run your backup heat, bring up the space temperature in the building, and then turn your geo back on. If it's below 50, we could run the risk of getting into that low pressure lockout in heating mode. Usually about 60 degrees or so is where we want to do startup and get the building up the temperature. Inside the unit, obviously low pressure refrigerant. If you are low on refrigerant, you've got a leak somewhere. So make sure you're checking for refrigerant leaks. TXV could be stuck closed. Basically, we're going to pump down when that TXV gets restricted like that. So it could be a TXV issue. Again, low pressure switch or board as well. You know, make sure we're always checking those components as well. Low pressure in cooling mode, should be cooling mode here. I apologize, it says heating mode. Because low pressure in cooling mode, we're going to look at the air side or the load side of the unit. So outside the unit, obviously dirty air filters, airflow issue. You know, you got a blower that's not operating, it's spinning backwards, something like that. Restricted ductwork, zoning issues, return air temperature is too low. If you're below 60 degrees in cooling, the coil could start to ice up. Normally, if you ever go out to a unit and it's a big ball of ice on the air coil, that's normally an airflow problem. If you have low refrigerant, the air coil might frost up, but it won't normally be a big ball of ice. That's usually caused by airflow, not enough airflow. Inside the unit, again, inoperative blower, dirty air coil, something along those lines. Obviously, refrigerant low, make sure we're looking for a leak. And TXV is restricted. I'm sure none of you guys have seen a TXV restricted before, but occasionally we have that problem. Low pressure switch or a board problem as well. On a water-to-water unit, high pressure lockout, again, this will be the load side, so we need to look at our load side water flow. Inoperative pumps, you got an airlock in the heat exchanger, maybe your zones aren't opening, and so you're not really getting flow through the zones and back, so we're not getting proper water flow. Some of our units will have a flow switch, some of them will have a thermistor that's looking at refrigerant temperature and deciding whether we have flow or not. The flow switches, normally we have to have at least like 4.5 GPM. So if we don't have zones opening, we could actually deadhead the pumps as well, but we won't get proper water flow. So Too much antifreeze, so we're not transferring good heat on the load side. If you're only doing heating, we don't necessarily have to have antifreeze on the load side, unless it's running in through like a floor zone that's in the garage or something like that, then I would highly recommend it. But if you're doing any kind of chilled water with a water-to-water unit, then we definitely want antifreeze on the load side, and make sure we've got proper amount of antifreeze. Water temperature set too high. Normally we don't want the water leaving that unit, I would say anything more than about 120 degrees. We start getting into the WT unit and we're running about 130 coming into the unit, we're going to cause the water leaving the unit to be somewhere around 140 degrees. So we could definitely run into some problems with high discharge pressure when we get that high temperature. Lower water temperatures are better. Obviously, the unit's going to run more efficient and it'll last longer. Normally, we can set our aquastats. We can either do that on a water-to-water unit with outdoor reset, which is probably the best way of going about doing it, the most efficient. Or if you're going to set it at a set temperature, I would probably stick somewhere around 100, 105, 110 max. Inside the unit could be overcharged. If somebody's been doing some work to it, make sure you're looking at that. TXVs, again, high pressure switch or board problem. A lot of these, faults are kind of repetitive. Again, there's not a ton to go wrong in the unit. Again, TXV, maybe the valve is sticking in cooling or something like that, the reversing valve, but normally a reversing valve issue, you're not going to see a high or low pressure situation. You're going to more than likely have a capacity issue and your refrigerant pressures are going to look kind of crazy. They won't be equal, but a lot of times they'll be close to equal if it's, sticking mid position or something like that. Low pressure lockout and heating mode on a water-to-water unit, that would be the source side of things. So we're going to look at your water temperature below 55 degrees on your load side could do it too. So if you're coming from cooling to heating mode and your tank is cold, you may have to jumper the low pressure on the unit and get it above that temperature, because we could run some low pressures with that low load water temperature. Source water flow is restricted or inadequate. It could be froze up too. So if you don't have proper antifreeze in your load side, or your source side, then it could be freezing up prematurely and not getting water flow. Inside the unit, obviously low on refrigerant. If it is low on refrigerant, check for a leak. It didn't come from the factory, low on refrigerant. It's impossible for it to leave the factory without a proper charge in it. Now, it's in shipment, it could rattle around and cause a leak, but just know that it didn't leave the factory with no refrigerant in it. Again, TXV restricted or seized, and low pressure switch or a board problem. If you get a source freeze or a flow lockout, depending on the type of unit you have, look at the lockout board and it'll tell you on the lockout board where the red light is for that FS lockout. If there's nothing hooked to those spade terminals, then you have a thermistor, a T4 thermistor that's mounted on the refrigerant line at your source heat exchanger. If you do have wires hooked into those spade connectors on the FS terminals, then you have a flow switch, which is basically a paddle switch that's in the source water line, and the water closes that switch. So you'll have to know which exact unit that you have. The newer units are going to that T4 sensor. Some of the units with anything with a braze plate will have a flow switch, but it could have a T4 sensor as well. The braze plate manufacturers require us to put a flow switch, a paddle switch in the water line anytime we're using a braze plate. So obviously water flow is restricted. Look at your pressure drop. You could have flow going in the wrong direction. Whenever in doubt, about the stickers that are placed on the unit, whether they're in the right position or not, refer to the IOM, because it'll tell you. I have seen a few times where the factory put the stickers in the wrong position. And it may not even lock out. It would if you have a flow switch, but it won't if you have a T4 sensor. Because T4 sensor is not even actually looking at water temperature, it's actually looking at a refrigerant temperature. On a T4 freeze sensor lockout, check the sourced water flow, but it could be a refrigerant problem because, again, T4 sensor is monitoring refrigerant temperature. So, you get around 50 PSI, and you're gonna, if you convert that to temperature on our pressure temperature chart, that's gonna be somewhere around our freezing mark. So that T4 sensor is looking at refrigerant temperature and not water temperature. So it could be a low pressure problem and not an actual flow problem. A lot of times I see it lock out on T4 sensor before it locks out on low pressure because the T4 sensor responds faster. So it'll throw you guys off a little bit when you see that that FS lockout, and we tell you, hey, check your refrigerant circuit. You could have debris blocking the coil, the heat exchanger scaled up on an open loop. You can back flush and clean it out. And again, you could have air in your loop. Make sure you're flushing your loops and make sure your pumps are running. Could obviously be low on refrigerant, so with that T4 lockout. So make sure we're looking for a leak if you do find it low on refrigerant. Could have a TXV that's restricted or seized. That will give that T4 lockout. Obviously, there could be a board problem or a sensor problem. If you've got a T4 sensor there, the sensor could be reading the wrong temperature, open or shorted. I will say that normally those T4 sensors, they don't read a wrong temperature. They'll normally just fail either open or shorted. So if it's reading resistance, it's probably good. If you have a load freeze sensor lockout, that's a T1 sensor, and that's looking at if you've got a water to air unit, it's looking at your air coil. So your airflow could be restricted or inadequate. Make sure your blower is changing speeds or make sure it's spinning in general. Check your filter and your static pressure across your air coil there. You could have a low return air temperature, inoperative blower, dirty air coil, debris blocking the coil. Obviously, you could have a low on refrigerant as well because, again, that T1 sensor is looking at refrigerant temperature and not actual refrigerant pressure or airflow, or it's just looking at refrigerant temperature. So you could have a TXV problem, board issue, low on refrigerant. You could have a sensor issue. Make sure that they're plugged into the board properly and ohm them out to make sure that they're operating properly. So there's just some of the troubleshooting on the unit itself. If you got any questions, let me know. And I'm not exactly sure what webinar we're having next week, but I know that there is one on Wednesday next week. So hopefully I'll see you guys there next week. If you need anything, please feel free to reach out, and we will talk to you soon. Thanks for joining today. I appreciate it.